And we'll turn on captions. Hello, welcome to Expanding Students' Worldview with Data Science in Social Studies. My name is David Hay. I'm working with Cybera, and I also work for Elk Island Public Schools just east of Edmonton. And if you want to find me online on Twitter, I am Mr. Hay. Also with me is Verena Roberts.
I am Verena Roberts. I'm coming to you from Calgary, Alberta, and I teach with Rocky View Schools. And if you want to find me online, I am at Verena NZ.
And if you want a copy of this slide deck, it is the link there, bit.ly/3nd. Anyway, you can see that. I don't need to read it out to you. And it is Creative Commons attribution, as you see at the top here. So feel free to make use of anything that you find useful from here. We're going to talk about expanding students' worldview, globalization, geography, government systems, economics, all of these sorts of things that we're talking about all the time in social studies. We're going to look at how we can use real world data to do comparisons, look at trends, and compare current situations to historical situations, all of those sorts of things, as we love to do in social studies, but looking specifically at that with data science. And some data sources that we'll be talking about, things like Gapminder and Wikipedia and all of those sorts of things that are excellent sources for data. And we'll look at curriculum aligned resources that have been created already through the Callisto project that we're both involved in, and help you kind of get started with that. So the Callisto project is a collaboration between Cybera and the Pacific Institute for the Mathematical Sciences, with funding from the federal government through the CanCode program. And Cybera is a technology accelerator here in Alberta. Pacific Institute for Mathematical Sciences is a consortium of math professors, essentially from universities that you see at the stars there. And it's really about making open educational infrastructure and learning resources available for data science, computational thinking, and data literacy in general. And so we do teacher training and student workshops, and we also are involved in a research project through the University of Alberta to assess the computational thinking and data science outcomes here. Over to you, Verena.
So when we think about, there we go. So when we think about the importance of storytelling in particular, storytelling has been around since the beginning of mankind, you could say. It's so important for communication, building cultural experiences, critical thinking, and problem solving.
All right, and it looks like our titles are not working when you talk, so I might just turn those off. Uh, let's see.
Oh,
Yeah,
I see what you're
that's
saying.
interesting.
Okay.
Okay, that's fine. It was worth a shot anyway.
We tried,
Yeah.
yeah. Oh, that's interesting. Anyway, go on. Now we learn. That's what Cybera is all about.
Yeah.
So keep going. The importance of data science. Go
Yeah, so
on.
really it's about finding insights and communicating insights from data, and perhaps as we get more into it, about making predictions of if we change this, then this might happen, or even prescriptions of if we want this outcome, then we should change these things. And there's just a couple of kind of visualizations there that really data science, a lot of it is visualizations and taking data and doing interesting things with it.
So I can. There we go. So when we think about data literacy and compare and contrast what we think of literacy in particular, data literacy is often considered more numeracy focused or math focused. But on the other hand, it's also really about emerging curricula and interdisciplinary learning, which is what we're focusing on in terms of data science. So it's using the power of the internet to explore big data sets, but really to integrate authentic, relevant, emerging trends and current events and things that are happening in modern day rather than just examples that we can use from the past. fast. And also, it's really easy to tell stories using data visualization. So what we did here is we integrated the data science bit, which integrates the interdisciplinary bit, but literacy is also about data collection. So when we're looking at bias, filtering data, choosing data, tracking data, what that looks like. And most importantly, that we're getting to really in some of the projects we're working on now is the communication component and choice in how we communicate our storytelling using data, which develops what's called multi and trans literacy for our students. Data science analysis process can be looked at from this perspective, where we look at understanding what's going on, the understanding of the data and looking at the data, the gathering of the data, the organizing, exploring, interpreting, and finally the communicating. And I think what's important here as a teacher is sometimes I would jump straight to the communicating or interpreting without looking at the other steps. And so that's really important and something to consider as we go through this with this presentation today.
Yeah, and so visualization really helps with that storytelling process and with the analysis process. And usually, when we talk about data visualization, we're talking about tables and charts and graphs and those sorts of things that sometimes we leave for the math or science teachers, but definitely that's applicable in social studies here.
Sorry. So when we think of the data visualization learning progression, the idea is, first of all, you'll see it's interpreting. Whoops, I'll move the other way. Interpreting visualizations. And right now, I'm literally interpreting the visualization on the screen and doing the opposite to what I think and moving. And what I mean by that is when we look at a graph or we're looking at something that is visualizing data, it's our interpretation and how we respond to it. Then the next step is creating visualizations with scaffolding. So how can we really understand and pull apart the data? And that's where we go back to using those computational thinking strategies in order to get a better understanding of the data.
And so these are some examples of visualizations that I thought were kind of cool things. So first of all, the looking at how our country voted in the last federal election, broken down by province or territory here, but then it sort of transitions to, okay, well, where are the people actually at? And we can see that, as they say, geography doesn't vote, people do. And that's a good visualization of it. And that was inspired by something that came out of the U.S. election, that looking at how the geography is different from actual where the voting stations were and such. And then over on the right here, we have four different visualizations, Anscombe's quartet, it's often called, where it's four different data sets with the same uh, slope of the line of best fit, basically the same statistics to all of them, the same average values and such. But obviously, when you look at the visualization, they're all very different. And so maybe a line doesn't fit well for some of them, but we don't really see that until we actually look at the visualization. And then, of course, the classic data source, where if you looked at this as a data set in a table, it wouldn't make any sense. But as soon as we actually plot it on an X and Y coordinate system, we see the data source that comes out there. And if you click on this data source notebook at the bottom, there's more of an explanation and actually how you can generate that visualization from the data table that's included with it.
Um, David, oh, can we just go back for one
Yeah,
second? So for the graphs on the side, they all have the same mean. Is that right? I just want to clarify that.
yeah,
Okay. Yep.
yeah,
Yeah.
absolutely.
Okay. So, some of the ideas when we're thinking about scaffolding data visualization, there is a great project known as What's Going On in This Graph, and it's through the New York Times. And what they've done is they've taken a different graph every week and they ask some questions around it. And it's all created for teachers already. And the idea is they're trying to help support the scaffolding piece of how do you look at data, how do you interpret data, how do you visualize data, and the perspectives that can come from looking at different data from from around the world. So maybe we'll just go in really quick just to show. Yeah. What we did is if you click on that link, you'll see all the different examples of the different data visualizations of the week that they've done. And if you click on one of them, David can choose any one in
Uh,
particular.
sure. Let's look at this COVID-19 related one.
Okay, perfect. So what they do is they ask a guiding question at the top, then they give you a specific visualization, and you'll notice that the graphs change every week. They make it really contextual. They make it really relevant. They make it about a topic that's going on right now. And here we're seeing how the consumer spending has changed during the pandemic. That's something that we can find data sources on before and after COVID, so it's an easy comparison. We have the previous year, we have the previous month. They show you how we're spending more or less. Do you have any more comments on that, David? What are you seeing when you look at this one in particular?
Yeah, it's interesting that the non-store real retailers, and that's something
Mm,
obviously we've seen happen, but that category has seen an
a rise.
increase
Yeah.
of 22.4%, and clothing, especially probably lower body
Yeah.
half of your clothing has really gone down. That we're not spending as much on that. We're not spending as much on gas and things like that.
And then you could have conversations about the impact of that as a result. For example, more pajamas in particular might be bought, but no jeans. But in gas stations, what's the impact on the climate as a result of less people buying gas? Then underneath, they have a very brief description of a little bit of an analysis of what you see. And then they ask you using kind of an inquiry approach is what do you notice? What do you wonder? What impact does this have? What is going on in this graph? They encourage other students around the world to come together in conversation so we can actually see through a hashtag what other people are thinking. And this one in particular, they were trying to get people to have an answer by a certain time. And then they summarize those answers and share those different perspectives out in the world. So the one of the best things I think about this is, if, especially from a US perspective, is they're encouraging different perspective from different geographic areas across the US. So they're trying to get out of that idea of a filter bubble. And so you get to see what other people think. So we have all those listed in the PowerPoint, and you can go in and you can click on the ones you like. And in our case, I can't remember what the next slide is, but I'm hoping it's the data visual. Oh, we'll just say then that Callisto and Cybera have created data visualizations of the week that we will be sharing as well. So we have it from a Western Canadian perspective, I guess you could say. And we'll have those links as well.
Yeah,
Now,
and
what's this? Yeah, oh, go on.
oh, I
Yeah,
was just going to say, yeah, those links are on callisto.ca.
yeah.
Uh, yes, this video, I don't know if you want to talk about this a little more. We don't necessarily need to show it, I think, but
No, just talk about it. Yeah.
yeah, Hans Rowling created Gapminder and wrote a book and a few other things. But this is, I think, from one of his TED Talks about visualizing data and looking at how trends have changed over time. And I think this is probably the famous bubble visualization of fertility rate on the x-axis, and then I think GDP per person on the
Mm,
y-axis, and how over time, back in the 50s and 60s, we had this gap between the developing nations of wherever they're from, and they had a high mortality rate, and so a high birth rate and low GDP per person. But we've seen as GDP has increased, or depending on which factor you figure is the
mhm,
causal factor, but GDP has per person has increased and fertility rate has decreased. The lifespan in all of these places has increased, and all of these things. And so we see now in 2020, 2021, we don't have that gap between the rich places and the poor places in quite the same way. We still have gaps, of course, within countries, and we could have discussions about the erosion of the middle class and all of those sorts of things. But if we look at things on a world per country scale, his argument has always been that things have been getting better, and it's very he's very enthusiastic, and it's great to watch these videos here. Uh, oh yes, we have a link to that bubble chart, and so you can actually use it in real time. You can click on it, and uh, hopefully we'll get it to load here. Data only goes up to 2019 at this point, but income versus life expectancy. So this is a different graph than the one in the video, but again, we see that sort of thing, and we can scroll through time here and see what it looked like. And you know, in the 1960s, we have a lot down here, and then some up here, with still some countries in the middle. But now everything is sort of risen to the right, up and to the right. And one thing I definitely like to show these days is if we started about so in the 1900s here, there's a big dip right at 1918. So you
Ah,
see that.
for
Uh,
the World War and Spanish flu. Is
yeah,
that what you? Yeah.
right. So there was a worldwide decrease in life expectancy right around then. And so just as you're playing through it, you see that little blip, and you can have that discussion with students, and how does that relate to what's happening right now, and all of those sorts of things.
And each of those bubbles represents a country. So that's like what we should, and the
Oh yeah,
population, I believe, of their country. So just so we know. Yeah.
yeah, absolutely. So the
Those
big one,
places.
China there.
Yeah.
Here's the United States, Japan, all of those sorts of things. And the bubbles actually change in size over time as the country's relative population changes, uh, those sorts of things. And you can even look at, if you want to find a particular country, if you're interested in Belgium, you can uh, click on that one and see what happens over time in
What
that.
I like about this is the interactive piece and the fact that in social studies in particular, I tend to use 2D visuals. And this gives you a 3D interactive opportunity to think about history and data in different ways,
Yeah,
especially in order to tell the story of what might have been happening at that time, like you're saying, David, for sure.
absolutely.
Oh, so this is a really easy way to learn about what's trending or what's emerging in Google searches around the world. So this is a specific tutorial.
Oops, let's not click play on that.
Yeah. So what you will do is we can use that. There you go. So you're going to click on one of the trends and you're going to pick a topic, something that you have searched about. So David, do you want to put in a random topic? And you can actually put a topic from a set location as well. So you can think of more people who have looked for whatever topic from a set area. So he's putting in Star Wars. He's looking in the United States in the past 12 months. How many people, or what's the interest of people clicking on and looking at searching for Star Wars? Now he's separated it worldwide. So Hungary, wow, is like the top country looking for Star Wars, searching for Star Wars at a certain time, and then he can compare it to like, what are you gonna do? Star Trek? Oh, I
Oh,
knew you.
absolutely.
So, oh, that surprises me. So, Star Wars is definitely more popular even in the last 12 months worldwide, and Star Trek has been kind of static as we go along. However, there's some blips. So, we can go back in the search history to figure out what happened during those blips. We can also see that Chile, fascinating, the countries who are intrigued by the Star Wars and Star Trek comparisons, or lead the way in searching for it. But there's things that you can do. For example, a student of mine he looked at it was a WWF fight. And so he was comparing and contrasting how many times those specific people came up within Google searches. And then he tracked what was said during that time in the Google search. And then he was able to see how marketing and saying that you're going to win a fight doesn't necessarily mean that you will win the fight. And the quieter person, or the person who wasn't as loud on social media, actually ended up winning the fight. So he created a whole story about it and was able to share with us his results as a result of using Google Trends. So that was his story based on Google Trends.
Hmm.
considering different narratives and perspectives. So, this is about looking and thinking about when you see a graph or you see some data, thinking about the bias in that data visualization, in that data source. And what we mean by that is you can actually break it down using computational thinking skills to try to think about why this data even exists. So, the first question, I think if we skip to the next slide or the first breakdown, yes, is funding. So, who paid for this collection of data? And you can often either find it, and if you can't find it, that's something that the question that you can ask. You can go investigate. The next question is motivation. So, why does this data even exist, and who decided that this data exists, and what purpose is it serving? So, for example, if we look at like an open portal for the city of Edmonton that talks about how many times or something about garbage collection or where we put the garbage bins in a park, that kind of thing. It's who decided that we need to know about garbage collection, and why do we need to know where garbage collection is within the city, and what the timing of it, that kind of thing. So that leads into the next one, the project design. There's usually a person behind the whole collection of data, and who was that person who operationalized, planned, or coordinated this design process for the data to be collected, because that person will have their own bias, or maybe their job requires them to be biased in a certain way. So these are all things to consider. This is not a bad thing. It just means things to think about. Next, we have how can you trust your data? So, where is the data coming from? Is it from some random class, for example, a class collection of data versus UNESCO, or a global organization that compares and contrasts data? Or is it from a specific organization that may be a lobby group? And we can talk about lobby groups with your class, and why they would have some data over others. So that next step would be, and then what are your bias, or what are other people bringing to the data analysis? So thinking about your perspective before you go in.
And
Interpret.
actually,
Oh, go on.
the
Yep.
question I often use for the data collection and sourcing, and also for the analysis, I mean, you can think of a silly question like, have you stopped hitting your children? You know, that sort of question will be a bias designed
Yes.
to it, and so how trustworthy are the data, and what was the bias that led to that question even being designed.
Yeah, that's a really good point, because you're saying the structure of the question itself, and the bias behind that question.
Hmm.
And then we get more to the interpretation. So when you go and look at some of those examples in the Times, you'll see that some of them really sway you one way or another based on the type of graph that they've chosen, or the way it is displayed. And how it compares to the actual mathematical or statistical results, just like the dinosaur, for example, or the different means, or the mean averages. And how will humans perceive and interpret the data? What are we trying to do when we get them to look at a visualization? And is that visualization ethical or accurate, or full of bias? Why or why not? So all these questions really lead you into thinking. It's called a biography, a data biography, and to help you figure out data, a little more about data. Next are online hackathons. So this is where we actually, I would say, yeah, encourage storytelling and action. Now you've disappeared. There you are, David. Go ahead.
Uh, so this is something that we started doing. We started doing some student hackathons back when we were able to do in-person hackathons, and then pivoted to online hackathons. And so with Cybera, this is, or with the Callisto project, this is something that I think has been quite successful, of having students involved in the process of, here is a data set, or here are a bunch of data sets, here are some tools for analyzing them, and we want you to tell some stories based on that. We want you to come up with some insights, some visualizations, and communicate your findings from it. And so this can be over a short period of time. We've done sort of 3-hour hackathons. We've done across a whole weekend. And other things like that. And so some of our colleagues, actually, I think Verena probably led this up, making a planning document for
Oops,
constructing a hackathon.
wrong way. There
Um,
you go.
that we can make you disappear there. So
Yeah.
that
Okay.
the link to it is in this slide deck, and so you can have a look at if you're wanting to plan your own hackathon or be involved with Callisto in planning a hackathon. There are lots of resources here for starting that process.
Yep. So
Oh, and then computational thinking is related to data science and that's really where the Callisto project started, and it's sort of transitioned into being about data science, realizing the importance of that. But computational thinking is really it's partly about being able to do coding and to get the computers to do things for us, but it's more about the algorithmic thinking, the identifying patterns, the decomposing problems into parts, and all of those sorts of things are what we do with computational thinking, and that's something that's not just applicable to math. It's applicable in social studies and in all of these sorts of things. So thinking about asking questions that computers can solve for us, and breaking things down into to manageable parts or repeating parts or all of those sorts of things is what we're talking about with computational thinking. And so this is a great little visualization that we've borrowed from barefoot computing about what that process looks like. And we have a few different ways that we can create visualizations. We can use code as, relating to computational thinking, and that can be in Python or JavaScript or other things like that. And we'll take a look at some Jupyter notebooks that allow us to do that, and about what visualizations can look like in that. But of course, we can also use spreadsheets. We can have them, and I think we should have students creating visualizations by hand, either taking some data that you put up on the board and they make it on graph paper, or some sort of hand drawn charts, or doing things digitally but by hand. I think I have an example on the next one. I have an example
it'll
at
be
some
after
point.
that. Yeah.
Sure.
Yeah.
Of something like that we can do digital but by hand, kind of painting things. So all of these ways to create visualizations.
We'll just do this really quickly. And this is a visitors and resident mapping tool. And the reason this is in here is to help students demonstrate visualizing their data and thinking about how we can integrate these kind of computational skills in ways in our social studies classes or English classes. So this is where you're asking students, where do they go and get their technology from, and what spaces in which do they learn. And so you're in specifically you're looking at digital spaces in which they learn, and a visitor is where they just go for the moment, and they'll go get something. Like if we think of it as a garden shack, they go and get a tool from their garden shack and they'll put it back, whereas a resident is something where they'll always have this tool and they'll always use it. So in digital tools ways, a visitor might be a search engine, and that you go look for something and you leave again, although as I'm with all these data people right now, so I will say that you never actually leave. Like you're always there. Data is always tracking. So I'm just saying metaphorically. Whereas a resident, you're always using your emails, you're always using your WhatsApp, you're always using TikTok or whatever it is that you're in. And then the next line that we'll see next is the where you do this in personal digital spaces where you think you're learning. Oh, or sorry, you don't call it learning, but you're going in and you're doing it in a personal way, versus an institutional. So your institution is asking you to do it. So institutions are learning management systems, Google Docs, things like that. Personal digital spaces might be Twitter or social media or other things. Now we'll just show you quickly how this could be visualized. You'll see that the students will draw, I am a visitor in an email. I'll go in quickly and I do it. My personal email is very restricted, so it's up in the top corner, whereas they're a resident in Twitter. They also use it in personal and in institutional contexts. What's interesting is he used only squares here, but there's an app that you can use for this and other ways. So students are encouraged to go in and use different colors, different shapes, different ways that they think about their space and tools in which they learn in digital spaces. What I do with this is then I ask the students to finish their map, and then they switch maps, and then they tell each other what they see. So they are literally communicating in a different, using data to share a story or share a perspective about another person. Okay. And that's the student version. So you can see how their perspective of where they learn and what they learn with in digital spaces is interesting. And it's mostly, as I see up in the top corner, they're learning in very personal ways. So as a teacher in K-12, you think, how can I integrate some of these learning spaces into my learning in the classroom? So kind of bring it down, I guess, literally bring it down into the bottom space. Okay, but this is what you were talking about, David, the examples.
Yes, absolutely. So the the on the right here, this is a visualization that I drew in my VR headset with three-dimensional painting, and I should have probably picked a better. I was just standing on a balcony, but should have picked a better wall to draw it against. I did. I recorded a video for my students the other day. Now that I'm teaching online, of solving a math problem, and it was very cool to see in the chat that they're like, "Mr. Hay put on put on a VR headset and recorded this video for us," and that was an interesting hook for them. So that was a hand drawn visualization using a digital tool. And then these on the right, or sorry, on the left, I guess, are from the Dear Data project, which was basically two people on opposite sides of the Atlantic, I guess, for a year. They sent each other postcards back and forth of different visualizations of data. And Verena, I don't know if you wanted to talk more about the project there.
Nope, nope. That's all I
Okay.
was going to say to that. Yep.
Yeah, yeah. So you can check that out. There's lots of interesting things, and it ended up being a website and a book that came out of that.
So just want to say we have about 15 minutes left, David, and we want to do Jupyter Notebooks and Gapminder, probably.
Okay,
Yeah.
excellent. So on the right here is Gapminder's Dollar Street project, which is a very cool thing about using images as data. So they took photos all over the world of families' living situations and correlated them to their monthly income, I think normalized to 2011 US dollars or something like that. And actually, my wife in grade three social studies uses this all the time for comparing different in the different countries that they're talking about, what do living conditions look like? And what they find is that things look similar across countries based more on income level than on where they are. So a family making 20,000 a month in France looks pretty similar to to a family making 20,000 a month in Canada. So a family making $284 a month in Brazil would look very similar to one in Tunisia or in India or any other place at that income level. The I think the tagline for the website is photos as data to kill stereotypes. So it's not that the whole country is very poor or very rich or something like that. And then this on the left, the chart of the day is similar to uh, the New York Times one that we were
Data
talking about.
visualization. Yeah,
Yeah.
data visualization.
And so
Mhm.
again, just things that you can, and the nice thing about these is they are all Creative Commons,
Mhm.
most of them are Creative Commons attribution, share alike, and so you can put them in front of students and say, "What do you see in this? What is this, talking about? What do you think? Notice and wonder, and all of those sorts of things." Oh, and there's a little more about the Dollar Street to see how people really live is what they're talking about. So 30,000 photos available on the site, and definitely something to check out there.
And finally, we get to how do we take these visualizations and adapt looking at how they are actually created. So on our data visualization on Callisto, you'll see that we actually include the Jupyter notebooks and how we created the actual data visualizations using coding. So that's what we'll hopefully get to next.
Hmm.
Yes, good.
Yeah, so a Jupyter notebook is basically like a document, a text document that has different sections to it, and each of those sections is referred to as a cell, and a cell can be formatted text with bold and headings and all of those sorts of things, or a cell can be actual computer code, Python or other programming languages that will be code that actually runs. They can make adjustments to it and rerun it and all of those sorts of things. And the Callisto project has a Callisto hub that all of these Jupyter notebooks can run on. Google is running one that's great. IBM Watson Studio has a lot of cool features, and there are other places you can even run Jupyter notebooks. You can install Anaconda on your own computer and run Jupyter notebooks that way. But the Callisto Hub is probably the easiest way to do that. And so then we have a bunch of links in this slideshow and on the Callisto website that will create copies of Jupyter notebooks that you can then edit and run. And if you make mistakes, if you break things, you just delete it and click the link again and it gets you a new copy and those sorts of things. So it's not like these are shared notebooks where you're going to be editing the one that your students will also be looking at or anything. They'll each have their own copies. And so as an example of the code that we can use for generating graphs, leaning this way, whatever. Anyway, you can sort of see the bar graph that was generated just from data that we manually put in here. So a couple of lines about saying we're going to use somebody else's library of code to make these math plotting things. So it's a math plotting library. Uh, we're going to put these things on the x-axis and these things on the y-axis to make this bar chart, and then just show it. And so students can use that. And I've had students as young as grade 5 who take this code. You show them this, put it up on the board, or paste it into your LMS or something like that, and say, hey, here's an example of a bar graph from these data. Why don't you make a bar graph of our favorite types of ice cream or something like that? And they can make some edits to the code and generate a bar graph. And then we also like to play around with circle pie charts and make some graphs. And so similar sort of uh, code to do that. In this case, we just say we have an extra line of saying the axes need to be equal, so that we want an actual circular pie chart instead of different shapes to it. But other than that, it's pretty much the same way. And again, I was teaching grade 6 social studies when we had our provincial election, and I showed the students how to do this, and said, okay, now based on the election we just had, find some interesting data and make some visualizations. And I had one group of girls that looked at all the people who were elected, and they created a pie chart of the gender of our MLAs, and saw that there were a lot of male MLAs that were elected. And then they also made a pie chart of the first names of the elected people, and because they noticed that there were 6 or 8 that were named Jason, and then just sort of one of each. And so that was an interesting pie chart as well that they had created. And then a very powerful thing here is the ability to pull in online data. And so this is basically taking a table from Wikipedia, and in just a couple of lines of code, it is pulling in the data and plotting this column on the x-axis and this column on the y-axis. And we get in this case, just a line plot of the the graph from that online Wikipedia table. And there are many other examples of how to generate graphs from online data in the Callisto repository as well. I can talk about these. So speaking of the Callisto repository, the notebooks that we have that are related to social studies, we sort of took a look through and curated some to take a look at. And so, for example, we have a kind of a simple one here on the capitals of Canada. Oh, and this is the Callisto Hub. You log in with a Google or a Microsoft account. Oh, and of course, because somebody's watching, it doesn't quite work. But we can uh, take a look at, let's just go this way.
And this is why it's so helpful having you here today, Mr. Hay.
Let's see what's
Um,
happening with this. Oh, it looks like the okay. We have other
yeah,
options as well. Uh, we could also run this on Colab or other things like that. Um, actually, okay. Let's take a look at the actual repository
yeah,
of all of these. So there's the data viz of the week, but the curriculum notebooks on GitHub, there are about, I would say, probably 100 of them. If we look in this social studies folder, there's the capitals of Canada one, and we see that it has these code cells and text cells interspersed. So this is all text, and I just this one I created. I took the data from a couple of different sources. Oh, I don't know what keeps doing that. Uh, but then there's the code to actually generate that, and we can open this in Colab to see what that looks like. Colab is Google's tool for running Jupyter notebooks. And let's run this one. And it's not authored by Google, but we still trust it. And from this, it generates an interactive map that allows us to see, okay, well, these are where all the capitals in Canada are based on their latitude and longitude. And if we click on any of them, we can see what the names of them are. We can zoom in and see, okay, well, so this one is there, those sorts of things. So that is generated from here, and you can have students actually look at the code and say, oh, well, there's the latitude and longitude, and that's how we label it. So it's basically just going through and making markers, and students can take this code and make whatever other graph they want. So, uh, you know, just adjust what the latitude and longitude are, and then display the map. And that's the great thing about these is all of it is included in uh, the code. We can see what's happening with it. And if we wanted instead to have a different tile set on the back of the map, oh, and it's not allowing me to scroll for some reason. Let's try the down arrow. There we go. So this is a map that looks a little different, or this watercolor one is kind of fun. And again, it's the same sort of. We can see where things are and what things look like in these different ways of visualizing maps. And then a few questions at the bottom. So that is the example of the capitals of Canada. We have ones on geography of residential schools with a lot more background to it and discussion around it, questions and things like that. There's a game for students to play. It's kind of like a paper-based, but instead of rolling dice to see if they survive or not, they run some Python code, and that's kind of fun. Some of these globalization ones that some of our colleagues put together are great for looking at globalization issues and how music is different, musical taste is different. I think that has some Spotify data sets that students like to look at. So all of these are examples that you can look at and try out. And then we have some other ones, some hackathon notebooks, some statistics with Shakespeare, or this one is designed for high school math, but you could use it in high school social studies as well in terms of getting online statistics. And then links to other data sources. And I think we're kind of running out of time here, but uh,
we're right on. Yeah,
right
so
on.
keep going.
Excellent.
Yep.
Yeah. So uh, the uh, the way to get started is basically, as you saw, hub.callisto.ca, which 90% of the time is up. I don't know what the uptime is, but that's actually the first time I've seen it down. So I'm not sure if they're doing maintenance right now, but normally that should work. And then you can try creating these notebooks or using existing notebooks and things like that. One thing that we also like to do with students to get them started is using turtles. So if you remember programming from the early 1980s, those of you that are my age or so.
My age. Yeah.
Yeah, the turtle forward and turtle turn, right, and all of those sorts of things. We can do that in Jupyter notebooks and do some art or make some cool shapes with turtles driving around and things like that. So you can check those out. But the most important thing probably is the learning modules. There's a link for the Callisto website, but you can see it in the GitHub repository as well. But all of these learning modules that are aligned to curricular outcomes that you can start with, and you can make some modifications or use them as is and try them out. And there are people available through the Callisto project who can help out with that as well. And that's again just a review of what the Callisto project is. Verena, if you want to talk about kind of the next steps from here.
So next steps from here, you'll see some links about a feedback form, and we'd really appreciate if any of you have made it to the end of this video, if you could give us some feedback on it. We also have some new courses, especially a data literacy course on Callisto and a new website, an updated website. So if you click on it, you'll find some additional resources, including the data visualization and the new data literacy course. You can check out some learning modules, and you can always contact us if you go to the if you click on contact, you'll hit one of the either the communications people or ourselves. You can tweet at us, I guess, yeah, at Callisto Canada, and you can learn more on Callisto on YouTube. Thank you so much for watching today.
Yeah, and of course, feel free to contact either of us on Twitter or email, and take a copy of these slides and click through and let us know what you think. But yeah, thanks for watching.
Yeah, thanks for watching. Have a great day.